Section 3 is titled Multiplying Rational Numbers. When we multiply fractions, we want to multiply the numerators and then multiply the denominators. So you can see here we have a over b times c over d, and the answer is a times c in the numerator and b times d in the denominator. In the example, it's 3/4 times 1/2, so we go across the top, across the numerators. 3 times 1 is 3, and across the denominators on the bottom, 4 times 2 is 8. So let's multiply and write our answer in simplest form. That means that we always want to make sure that the fraction is reduced. So in example 1, we have 1/6 times 2/3. So we multiply across the top 2 times 1, and across the bottom 6 times 3. So that gives us 2 over 18. But this is not simplest form because both of these numbers are even. That means that they're both divisible by 2. So we need to divide the top and the bottom by 2 to get our simplest form answer of 1 over 9. Example 2, we have 1/2 times 4 over 10. So that's 1 times 4, or 4 on the top, 2 times 10, which is 20 across the bottom. Hopefully you recognize that 20 is divisible by 4, so we want to divide the top and the bottom by 4 to give us 1/5. Example 3, we have 5/12 times 6/10. So again, across the top, 5 times 6 is 30, and 12 times 10 is 120. Now, you may not know where to start here, but it turns out that 30 does go into 120. If you think about it, 12 is divisible by 3, so that means that 120 is divisible by 30. But you might start with an easier number like 10. Let's say you divide the top and the bottom by 10 because you don't recognize that they're both divisible by 30. So 3 divided by 10, that's 3. 120 divided by 10 is 12. But now you can see that 3 goes into 12, so we need to reduce again. Divide the top and the bottom by 3, and we get I multiplied. We get 1 over 4. Now I want to show you something else with multiplying fractions, something called cross-canceling. So I'm going to rewrite problem number 1 over here. Some of you may do this because you think that it's easier. You don't have to reduce at the end. Some of you, though, may still like to do it the other way, where you multiply across the top and bottom, and then you simplify. Well, what's called cross-canceling? That means that if you can take one of the numerators and cancel it with something in the denominator, or reduce the two numbers because they're both divisible by something, you can actually do that before you multiply. So if I look at the numerator 2, I know that 6 and 2 can reduce. 2 goes into 6, and 2 goes into 2. Well, I'm going to rewrite what that number is. 2 goes into 2 once, and 2 goes into 6 3 times. So my new problem becomes 1 over 3 times 1 over 3. When I multiply across the top and the bottom, then I get 1 over 9. Notice that was the answer. Let's look at example 2. We had 1/2 times 4 over 10. And you actually can reduce any numerator with any denominator. It can even be from the same fraction, but cross-canceling is the most common because typically when we give you a problem, it's already going to be, each fraction will already be reduced. But here I have a 4 that goes into 2, or excuse me, a 2 that goes into 4. So 2 goes into 2 once, 2 goes into 4 twice. But hopefully you can see that we're still not done because now we have this 2 left over with a 10 still on the bottom, and that fraction does reduce. 2 over 10, and I'm going to rewrite this so that we have 1 over 1 right now times 2 over 10. 2 over 10 reduces to a 5th because both of these numbers are divisible by 2. 2 goes into 2 once, 2 goes into 10 5 times. So now we have 1 over 1 times 1 over 5, which gives us 1/5. You'll notice that was our answer. So cross-canceling, canceling numerators with denominators, is something you can do before you multiply the fractions. Again, not everyone will want to use that method. You don't have to, but it is a little simpler because then you don't have to reduce at the end. Let's look at a few more examples. We have 3/4 times a negative 7/9. The first thing I'm going to look for is cross-canceling, and I see that the 3 and the 9 are going to reduce. 3 goes into 3 once, 3 goes into 9 3 times. 4 and 7, those numbers do not reduce. Nothing goes into 4 that also goes into 7. So now I just need to multiply my numerators and my denominators. Also, notice that we have a negative fraction, and a positive times a negative means our answer is going to be negative. So we have 1 times 7, which is 7, 4 times 3, which is 12. 7/12. That fraction is in simplest form. It cannot be reduced. Had we not cross-canceled, had we just done 3/4 times the negative 7/9, 3 times 7 would have been 21, 4 times 9 is 36. It would have still been negative, but now both of these numbers are divisible by 3. 21 and 36 are divisible by 3, so it would give you a negative 7/12. Remember, when you have a fraction that's negative, you can put the negative sign anywhere. It can go on top with the 7, it can go all the way out in front, or it can go on the bottom with the 12. Let's look at example 5. We have negative 9/12 times negative 2/3. Here I'm going to cross-cancel. The 9 and the 3 will reduce. 3 goes into 3 once, 3 goes into 9 3 times. Also, the 2 and the 12 will reduce. 2 goes into 2 once, and 2 goes into 12 6 times. If I rewrite what I have here, we have a negative 3/6 times a negative 1/1. Now you also may notice that 3/6 does reduce. 3/6 is a half. Remember, whenever the top number is half of the bottom number, that fraction will reduce to a half. So now I have negative 1/2 times negative 1/1. So first we need to think about the sign of our answer. A negative times a negative is a positive. Multiply the numerators, 1 times 1. Multiply the denominators, 2 times 1. Our answer is a positive 1/2. Again, you did not have to cross-cancel at the beginning. You could have multiplied across the top and multiplied across the bottom. Then you would have had to reduce that fraction down to 1/2. Let's look at some mixed numbers. When you're multiplying mixed numbers, you want to turn them into improper fractions, so we do that candy cane method to both numbers. 2 and 1/3 becomes 7/3. Remember, it's 2 times 3 plus 1 over the denominator, times 2 times 7, 14 plus 5, which is 19/7. Now we need to do some cross-canceling first. Those 7's both reduce. 7 goes into 7 one time. You're left with 1/3 times 19/1. So when we multiply across the top, we get 19. Multiply across the bottom, we get 3. Our answer is 19/3. This is an improper fraction, but as long as the improper fraction is reduced and in simplest form, you can leave it like this. You do have the option, if you want to change it to a mixed number, to say 6 and 1/3, but I will accept this answer. Example 8, again we have two mixed numbers, so we want to use the candy cane method to change them into improper fractions. 1 times 6 is 6, plus 5, we have a negative 11/6, times 5 times 7 is 35, plus 1 is 36/7. Again, I can cross-cancel. 6 goes into 6 once, 6 goes into 36 6 times. Once I got all my cross-canceling done and I can't reduce anywhere else, I multiply across the top. Notice again we have a negative times a positive, so our answer is going to be a negative 66/7. Again, it's an improper fraction. We look at 66, we determine that it's not divisible by 7, so we know that we can't reduce the fraction. This answer is acceptable, but again, you can change it back to a mixed number if you like. One final example, let's evaluate an expression. We have 1/2 AB, and we are told that A is 6/7 and B is -4/9. So remember, this is 1/2 times A times B. So let's substitute in 1/2, A is 6/7, and B is a -4/9. Multiplication of three numbers, they're all fractions, but that's okay. We go across the top, we go across the bottom. If you can cross cancel anywhere, you could. This one I'm not going to for those of you who may not like to cross cancel. What I want you to recognize here is that I could reduce the 2 on the left with the 4 and the 6 with the 9. But I'm just going to multiply all the way across the top in one step. 1 times 6 times 4. Notice it's a positive times a positive times a negative. Our answer, our final answer, should be negative. So 1 times 6 times 4, that's 24. On the bottom, 2 times 7 times 9. Well, 7 times 9 is 63. 63 times 2 is 126. Now we need to start reducing. If you're not sure what these numbers reduce by, just start with even numbers. We know they're both even, so they reduce by 2. So that's -12/63. You may not know what else goes into them, but 3, you can use a calculator to check. 12 is divisible by 3, and 63 is divisible by 3. So that gives us a -4/21. 63 divided by 3 is 21. This fraction does not reduce, so that would be your final answer. Now again, had you done some cross-canceling in the beginning, you wouldn't have had to reduce so many times here at the end. So I do think cross-canceling is a little bit easier because you are canceling smaller numbers versus at the end of the fraction after you've multiplied when you are reducing larger numbers. In class, we're going to work on worksheet 3.3.